Alright, video 3. Binary ionic compounds. Compounds composed of two elements are known as binary compounds. That's a vocab word. You need to know it. Could be on a quiz. In a binary ionic compound, the total number of positive charges and negative charges must be equal. Therefore, the formula for such a compound can be written given the identities of the compound's ions. For example, magnesium and bromine combine to form the ionic compound magnesium bromide. Magnesium, a group 2 metal, forms the Mg2 plus cation. Note that the 2 plus in Mg2 is written in a superscript, means above, superscript. Bromine, a halogen, forms the bromide anion when combined with a metal. In each formula unit of magnesium bromide, 2 bromide anions are required to balance the 2 plus charge of the magnesium cation. The compound's formula must therefore indicate 1 magnesium cation and 2 bromide anions. The symbol for the cation is written first. Ions combined in this way. So you're going to combine 1 magnesium, because 2 plus, and 2 bromides, because you need to balance out. If there's 2 pluses, you need to have 2 minuses in there somewhere. 2 negative charges. So the chemical formula is MgBr2. Note that the little 2 in Br2 is written as a subscript. The charges of the ions are not included in the formula. This is usually the case when writing formulas for binary ionic compounds. As an aid to determining subscripts in formulas for ionic compounds, the positive and negative charges can be crossed over. Crossing over is a method of balancing the charges between the ions and ionic compounds. For example, the formula for the compound formed by the aluminum ion, Al3, and the oxide ion, O2 negative, is determined as follows. First, step 1, and these are the steps you need to take in writing formulas. Write the symbols for the ions side by side. Write the cation first. So they wrote the cation first and the symbol for the anion next. 2. Cross over the charges by using the absolute value of each ion's charge as the subscript for the other ion. So basically what they did was they said, hey, we're going to move the 2 negative right here, and our 2 charge down here. And we're going to take our 3 charge and move it down here. Pretty sweet. And that's called crossing over. Step 3. Check the subscripts and divide them by the largest common factor to give the smallest possible whole number ratios. Then write the formula. Multiplying the charges by the subscript shows that the charge on the 2 aluminum 3 cations, 2, because there's two atoms, equals 6 plus, equals the charge on the 3 oxide anions with the 2 negative. 3 times 2 negative equals 6 negative. So 6 plus a 6 minus equals 0. The largest common factor of the subscript is 1. The correct formula is therefore written as Al2O3. Nice. Alright, another way of saying largest common factor is what is the simplest ratio of the atoms. For example, our ratio here in this says that there are 2 aluminums for every 3 oxygens. Can this become any simpler? Can you reduce it down to a simpler ratio and still be the same? Well, the answer is no. You can't. Let's continue reading on. Naming binary ionic compounds. The nomenclature, vocab word, the nomenclature, might want to write that down, or naming system of binary ionic compounds involves combining the names of the compound's positive and negative ions. The name of the cation is given first, followed by the name of, next page please, followed by the name of, the anion. For most simple ionic compounds, the ratio of the ions is not indicated in the compound's name because it is understood based on the relative charges of the compound's ions. The naming of a simple binary ionic compound is illustrated below. So here you've got the name of the cation, aluminum, and the name of the anion, oxide. So the name is aluminum oxide. Notice it doesn't say aluminum 2 oxide 3 because they assume you know that already from the charges. That's why you have to memorize these things. All right, let's do a sample problem together. Sample problem says, write the formula for the binary ionic compounds formed between the following elements: zinc and iodide and zinc and sulfur. Binary means 2. Ionic means that they're not sharing electrons. They're trading them to form ions. And they're a compound formed between these elements. Okay? So what we'll do is we'll read through the answer, and then we'll do one of our own. Okay, here's the answer. Write the symbols for the ions side by side. Then write the cation first. You know, I've changed my mind. I want you to take out a piece of paper and label it practice problems. If you're doing your practice problems in your notes, change the color of your pen so it's very clear that these are the practice problems. When you have your paper ready, go to the next video.